the secret. So, okay. Many thanks. So, yes, got it. So the title of the talk, as you see, is a very pessimistic one. It's mad crowds and corrupt government. So let me explain something about the history of the problem, which is a very old one. It goes back to Condorcet. You probably remember that there is a so-called theorem of Condorcet that says that it's the jury theorem. It is, well, the idea is by now very simple. It's the trivial application of the law of large numbers. That is, suppose that you have a certain number of agents, it's the member of a jury, and suppose that they get a signal about, say, a defendant, that is guilty or not guilty, and suppose that this is a noisy signal, but it is still correlated with the truth. That is, you assume that they get a signal that is guilty or not guilty, that has a probability at least 1/2 of being true, okay, to make things simple, or something like that. You can also have some versions that are more, say, they're in with a continuous variable. That is, suppose that you have to guess what's the temperature today outside, okay? And so everybody can say a number. That is, I think there are now about 20 degrees, or 19, or 21, and so on. So the idea is that by taking the average of all these, or if we have a jury, by looking at the majority, if the jury is large enough, therefore, and this is very important, if the observations are unbiased, of course, and independent, there is a very high probability that we will reach the truth. So I think also there are some popular explanation of this. That it is at the level of there was a book whose title was exactly The Wisdom of Crowds. That is, you can do experiments. Probably you know this game that people play. That is, you have a pot with beans or peas, and you have to guess how many beans or peas are there. And you ask a lot of people, you take the average, and you see that the average is not only is quite close to the truth, but is also usually closer, if there are a lot of agents, than the best guess. See? So in a sense, the average is better than the smartest one in the group. And there were, I think, there are also stories about this. That is, there was a game, I think, in the 19th century in which you had to guess what was the weight of a cow or some big animal there. And the one that got closer to it got actually the animal. And so this is, say, we can say that this is a sort of wisdom of crowd. This is, we have a lot of people together. None of them has a signal that is very fast. They're all quite noisy. But by putting them together, the mistakes cancel each other. And then, of course, you know that there are a lot of results on the law of large numbers, so on, how to quantify this and quantify convergence and so on. But just to say, I will not speak about it. On the other side, there is well, you know very well Jean-Jacques Rousseau, and he had several passages in which he speaks of this general will, I think is the English name, volonté générale, that is not really the majority. And also, he makes a very interesting remark that he says, well, or really speaking of this figure of conversation, people vote, not only they have to be sincere and so on, but also they don't have to interact among each other. They don't have to talk to each other. Why? Because, well, if people communicate, then you see that the observations are not, or say the expression of the observation are not really independent. And so the law of large numbers or the central limit theorem and so on do not hold in general. or they hold only to a certain extent, you have to quantify. And then we can say that this type of behavior that may interfere with, say, the convergence to the truth is typical of what we call crowd. There is a book, probably some of you know it, it was in the late 19th century, by Gustave Le Bon, that is, whose title in English is Psychology of Crowd. And I disconnect the phone, sorry. Of course, yeah, very apologies for the telephone, and I am very disorganized, let's say, with a new condition. So probably you heard of this book, Psychology of Crowd, that it was also the inspiration, one of the inspiration for Freud, that he recognized it. And also Freud wrote the book Master Psychologie about more or less the same subject. So what is the thesis of this book? The thesis is that really, if you put people in the crowd, even if you put people that are competent and rational, they will exhibit a behavior, and they will take decisions collectively that are totally irrational. So Le Bon was a positivist, so he had an explanation that was really based, that he said, well, they are the reaction of the cortex, that are the higher function, and then they are the one of the lower center in the brain, and everybody has a different cortex, our individuality and so on. So these cancel each other, and what is left are the instincts. So when you put people in the crowd, no matter how reasonable they are, taking a single individual, they behave really only following instincts and this. And of course, this is what this is what Freud discussed. It is instinct, so the unconscious. So it's very explicit. His theory of unconscious was inspired by this book. And this book, unfortunately, was read and understood, but by several people. Among them, there were Mussolini and Hitler. And as you can see, they were able to exploit it quite well, because, particularly in Germany, you see, Germany in the 30s was probably the most advanced country. Usually, the German people had most people were very well cultivated, and this, and nevertheless, you know what happened. So, so why does this happen? And so this is the point of the article. It's trying to explain what happens when people, before expressing their idea or voting or whatever, talk with other people. That is, we would like to think that, you see, by talking to other people, you get a better picture of what's happening. You see, I get a noisy signal, other people get different signals. So by putting them together, as I said, the idea should be that we make an average, and this occurs, but it is not so. If you want to think of in the economic literature, there are this example of what is called herd behavior. That is, probably, you know, the simplest one is this. There are two restaurants. You want to go to a restaurant where a lot of people go. So you get two types of signals. That is, one, say, is the smell that comes from the restaurant. You see, it can be good or bad. But it's a noisy signal. The other thing is that you see how long is the queue in the restaurant. And then you combine these two things and you decide where to go. Well, what may happen? Well, you see that if, suppose that at some point, the first person that arrives there makes a mistake. So he starts forming the queue in the bad restaurant. Then the second one that arrives has two signals, has the bad smell that comes from the restaurant, and assume that he gets the right thing this time, no? He doesn't make a mistake. And but he sees that the other one is there. So he balances the two, and say, depends of course on the weight we put and this, but say, suppose he's indifferent. So he's indifferent, so we throw it one up instead. At this point, you have two people in the queue. When the other comes, what they do, even if they get a bad smell, they weight it against the opinion that is expressed by these other people that are in the queue. So you see two people in the queue, you get a bad smell, then but if they are there, probably they think that the restaurant is good. And so you tend to make a line that is longer and longer in front of the best restaurant. And then you can quantify it in some way, and you see that there is a high probability with reasonable weights and choices that people all go to the better restaurant. So this is an interesting model. There is a rich literature of this type, using this idea. They all make an assumption that is different from what I will speak about, because you see that here the process is sequential. That is, you arrive and you weight it, you weight your opinion, seeing what the other ones have to do. The other ones cannot change their opinion, seeing what you do. Okay, so it goes only in one direction. While, you see, when usually people vote or speak about politics in a cafe or this, they change opinion, but then they hear also the opinion of people before. That is, there is a bilateral. Okay, so now I try to share the screen. If maybe somebody can enable me, so I show some.
I think it should be good now.
Okay, thank you. Yes. Share. Let me close this here and open. I have, see, I didn't send the paper because it's very tentative, and then like to finish it. And I am also planning several extensions, so yes, here it is. Okay. Yes, and I put this quotation that this author that no, probably that I left off. So this is what happens in my paper, and what happens also in the is really what happens in the psychology of crowds. Is not only crowds tend to make their own decision often, but also they tend to change suddenly from one extreme to the other. Let's go back, well, to my country, to fascism. That is, people say that before the 25th of July of 43, everybody was a fascist. To give you an idea, among the university, there were at the time about 1,000 of university professors. The regime imposed an oath of allegiance to fascism, not to the country, not to the king, to fascism. And only 10 or 11 did not take this oath. This was really a scandal, because even the regime was astonished. That is, really, the reason why this oath was introduced is that really people knew that most university professors were not fascists. The sincere fascists were a minority. So it was an attempt to epurate these people, saying they don't take the oath, so they will be put. They were not even, you see, they didn't suffer anything. That is, they were simply put on compelled retirement. So they were getting a pension, and these people were usually very affluent at the time. The professor had a lot of other income. So it was sort of a rather minor punishment. Nevertheless, 99% was declared completely the allegiance to fascism. After 43, these very same people got certificates of anti-fascism. There was a market of this. So it was a sudden reversal. That is, people, you see, from one day to the other, people were fascists, were selling or hiding all their uniforms and this. And so why is this? Well, let me give you also another literary example, because then the mathematics becomes a little boring. There is an example in the Promessi Sposi that wrote it, I think in English, is this book by Manzoni, this novel. So at some point, people, by some reason, think that there is a famine, that is bread, there is scarcity of bread in Milan, and people think that a certain officer was responsible for this, while it was the only one that was honest at that time. We are in the 17th century. And that it was the only one that was trying to rationalize things, that is to prevent hoarding and this, and having some you see, dividing bread in a fair way and so on. But they got convinced of the contrary, so they assembled in order to lynch him from his house, because he was scared and this. And then his friend, who was another very popular politician, and he was very respected and this, comes to rescue him. And Le Bon, commenting on this, said, well, if he had been there and if he had tried to say what I just told you, that is, you see, really he's not doing this, try to reason, consider that we have so much bread, so many quantities, we have to divide it in so many quarters and so on, they probably would have lynched him too, saying you are, you see, a complice. So what he did, he arrived there and he starts shouting, yes, finally, I came here to hang him. Where is he? Something like that. He grabs him in front of everybody and he pushes him in his coach. And of course, then he said, well, stay down. And then, you see, he starts saying, well, you will see him with his body hanging next morning or something like this. And then he rescues him and goes back. So this is the typical example of irrational. So let's start with a model. That is this one. Suppose that we have a village or something like this, and that we have voters. Again, you see, there are many ways we can follow this also just to fix idea. And then we have a ruler. We suppose that there are these n villagers, and that the ruler has a budget X of T. So this could be, say, the national income of this. These are the resources that are available. The ruler is corrupt. So in this model, there are no types to begin with. That is, it's not that there is a corrupt type and honest type. That is, we make a rather strong assumption that politicians are corrupt. That is, if they can steal, they do it. Okay. So the ruler wants to subtract from X of T, that is the total amount of resources, an amount that is called P of T, that are bribes. This could be also inefficiency, laziness, in civil officer, whatever you say. The rest goes to the public. The villagers cannot observe X of T. That is, they know the law of X of T, but they see only W of T. So if W of T is low, they don't know if it is because they got a bad luck this time T, or if it is because the ruler has subtracted some amount in budget. So at the end of the period, there is an election. So the villagers have to express their opinion and decide if they want to keep the ruler or this has a model of this type is quite common in the economic literature, and is what is called, is taught in every elementary course, is the principal agent problem. You see, we have an agent that takes bribes, and the principal has to decide if he wants to keep it. And of course, we can write a game for this, and we can try to solve it, and depending on how we write it, the solution can be, you see, you can spend all the level of complication from something that is trivial to something that has not been solved yet. That is, it was, actually asked even a fifth medalist said, no, it is by far too far. But the idea is quite simple. And if you are happy with not with the optimal solution, but with some approximate solution, it's quite interesting. That is, if we assume, I don't know if I have it in this version. No, this is already the new thing. So suppose that you assume that the villagers are rational individuals, okay? And full rational, you see the standard frame of game theory, common knowledge, and that the ruler is fully rational. And suppose that the ruler wants to maximize, say, the discounted sum of the B of C. You see, when there is some discount factor and you want to this sum. What happens? Well, you see that an approximate solution, if the ruler is patient enough, the discount factor is quite close to 1, is to say, okay, the villagers know what is the law of across T. So in particular, they know the average. What they do is that at the beginning of the period, they are quite tolerant. You see, they don't do anything special, but they start computing the average of the X of T. Then when T becomes larger and larger, they compare the empirical average that they see with the mean of the distribution. And if this is below some epsilon, then they fire the ruler. You see, there is this idea. You can think of having it in continuous time, and then you have a Brownian motion, and you have to decide, say, particularly in the first period, you have really to define everything. But the idea is quite clear. That is, if the ruler is stealing for a long time, it will be eventually discovered. So the optimal strategy of the ruler is to have B of T that is quite small, that is decreasing, it depends on epsilon and this. All the point is really finding the optimal thing, that is, what is the optimal epsilon, or how it depends on, say, the factor of this. But if you are just happy with getting close to the average, you do. So it is that the problem in this case would be easy if you have a lot of time, of course. But really, things are different because what is the problem with this? It's not so much the fact that time is long, because you see, in many cases we have not the same ruler, but the same party or the same political system that lasts for a long time. And we can think that this T is not even a legislature, maybe it could be an year or something like that. That is, you see, this is not a problem. The problem is that this assumes a lot of rationality on the part of the individuals. That is, they must be able to coordinate each other, first of all. So you know that in game theory, voting games are really a catalog of paradoxes that if you can find. If you have questions, please ask them. I don't see the chat, but interrupt me and ask questions. So you see that voting games are full of paradoxes in which people do the wrong thing, that think that is Pareto minimal instead of maximal, and so on. But so first of all, there are these coordination problems in the vote. But even if we assume that they are all coordinating, there is the problem of rationality. We assume that all these villages are very good at computing, at taking average, that they have a long memory, all things that usually voters don't have. Well, I think both. Well, I was talking to Gael before. I used to complain about the way people are elected in Italy and people react when they are not elected, but I think that now something can be said also about the United States. Okay, so let's take another model. So we consider always this community. They have these voters. That period, we will call it a legislature. You see, T is each legislature. At the end of the legislature, there is an election. In each legislature, there are, say, days. That is short periods. Okay, these are the sub periods. And then we assume that each voter has a set of friends. Okay, so this will be the one whose opinion will influence things. Here again, you see how many extensions you have. That is, instead of talking to friends, you can go to internet, or you can read the media. So you see, in a sense, the media is sort of universal friend. It is friend of everybody, or is an anti-friend. You see, you may also think that some people express opinions, and hearing them, I will change mine. You see, if somebody likes somebody, I may think that I shouldn't like it. Okay? So in each legislature, you have this budget, and you can split it between the wealth of the voters, that is what they will observe, and the bribes. So the voters don't see X, don't see E, they see only X minus T, W. Okay, how do the voter behave? So this is a behavioral model. There is no utility function here. And it is purposely on this. That is, I think, a problem, we want to be a little philosophical, in some models of voting, this is individualism. That is also in standard economic theory, well, no better than me. These people are individuals, they maximize a utility function, but really, you see, what is important for us are relations. That is how we interact with people. It is not so much our utility, how much we consume, even now. And if we think that what is important is the utility, we even lose the utility. Okay, so assume that in each day you have an opinion. So you vote only at the end of the period, but in each day you have an opinion that may change. So the opinion of agent I in the legislature T and day D is +1 if you are in favor of the government and -1 if you are against. Okay? What happens is that during the day you speak with other people about politics, you see, about your friends. So you observe the opinions of the others that are communicated. You communicate your opinions to them. And at the same time, you observe what is the welfare. The welfare does not depend on the day. We assume that more or less it's the same during all the period. We could make it also vary, but it's not relevant. So you get a noisy signal. That is, you don't observe really WT, but you observe WT plus a noise that is idiosyncratic. So, for instance, you wake up in the morning, you go, you want to take the bus, and you see if the bus is delayed or not. So the bus may be delayed because there has been an accident, there is a big whatever, so this is the noise, or it is delayed because WT is low, because the government is not investing enough in public transportation. Okay? And every day you make this type of observation. So at the end of the day, what do you do? Well, you go to sleep, you talk to your conscience, and you say, well, what should I really think of the government? So there is a probability alpha that you change your opinion. So there is a probability 1 minus alpha that you keep the opinion in bed. You see, this, or you may think that you should really reconsider it. How do you reconsider it? You can reconsider and keep, suppose you are in favor. Either you don't change your opinion, so you don't think too much, or you may think, and you may decide that, yes, you are still in favor of the government, or you are against. What is your new opinion? Yes, it is this one. Well, the probability that you're in favor of the government is what? Is a function that depends on the welfare, W. You see, this is the budget, these are the bribes. So this is the W, the noise. So this is the observation that you made. Yes. You compare it with some reference. That is, you see, you would like at least a certain level of knowledge. It is the government should give you something. But this is influenced also by the opinion of your friends. So this J here, you see, these are your friends, the opinion that you heard during the day, you give them a weight, and then you take this down. Okay? So you have your signal, noisy, a sum, and then you have a reference value, that is where you go. How is this function F? We assume, and this is what is usually done in all the behavioral literature, that F is an S-shaped function. What does it mean? That, you see, if this number is very low, the probability this person is very low. That is, almost surely you will be, unfortunately, well, there should be a figure, but maybe I will go to the black box point and you will see. So if this sum is very low, most probably you will be against the government. If it is very high, you will be in favor. So the asymptotes are, say, 0 and 1, or well, they are normalized in this way. So 1 is 1. And then at some point, there is a step. You see the function increases. I think you see at least the first step. Okay. Yes, so we can think of two extremes. One is the one in which people do not talk with friends or do not care, so total individualism, so all the ages are zero here. And when we see that, say, this is the model of Condorcet, and he will tell us, you see, that everything works well, so there are no mad cows and the government cannot be corrupt. More or less for the reason we said before. Well, the problem is to decide what is the W0, but you take this W0 close to the average, just a little bit below, to prevent you from firing the government, particularly at the beginning, and then you can ensure to yourself this, say, reference value. That is the average of a short T minus. But then suppose that these ages are not zero. And to simplify things in this paper, we observe, say, the other extreme, that is everybody talks to everybody. So the set of friends is odd n, and all the weights are the same. So really what is important is the average of the current opinion. Well, you may say, well, not everybody talks to everybody, but equivalently, you may think of something like that. You take a sample. That is, you may think, you go to internet and you start reading what people write on socials. You see? And well, it's true that maybe on Facebook or Twitter or these things you have your friends, but you see, you also read a lot of things from people that you don't know at all. Or you see, you take a random sample from the population. That is, you go in a cafe and you hear what people say, and these are not really friends, they're just acquaintances of people that live in your town. So, and all these should be more or less estimated by this. So I think this is a good first approximation, and it may be changed, but simply the mathematics becomes more complicated. So how do you select the ruler? Well, this is quite obvious. This is at the end of the period, say at date D, week D, then you have an election. And you have an election, and if he has 50% or more, he is elected, and if she has less, she is fired. So here we have two problems. This is the problem of the ruler and how the people behave. The problem of the ruler is rather simple. That is, you want to maximize this expectation. Again, interrupt me if you have any questions. I just open this. And you want to maximize this expectation until you will be fired. So here you have a random time. As I said, it's a very, very easy problem in optimal control. I stop sharing and I show you a picture of the blackboard, okay, of what happens in this case. So let's go there. I get close to the board. If you don't see what I'm writing, I prevent you. I close the window, so you don't have the light of the window video. The camera. Okay. So what happens is the ruler has to, yes. Suppose that this is the amount of price, P of T, and it's quite easy. And suppose this is what it will get. So it will get the number, the price, plus the expected value of what it will be able to steal from the next period on. You see, this is you see the standard Bellman equation. So it means that it will start. You see, suppose it takes no bribe, it has that. But then it will start getting things. Sorry, no. If it takes no bribe, it will have what it would get if from the next period on, if he is using if she is using the optimal strategy. Then she may think, yes, but I take some bribes. Okay, I go up. But I cannot go up at infinity, because if I take some bribes, there will be a probability that I will not be elected. And you see that typically this probability has a sharp peak. So at some point here, you jump to this level. That is, you start taking bribes. At some point, you steal so much that your probability of being elected decreases dramatically. And so what you're left with is only the bribes that you get in your in the first period. And then you can think of taking even more bribes, until some maximum. And you see that the only problem here is that you are trying to maximize something that is not convex. So there are, the solution is not continuing with this, but this is not, you see, this is very simple and easy. So what is the idea? Well, suppose that this level here is higher than this. Then we have what we could call kleptocracy. That is, in this case, so this is lower, this is higher. What you do is that as soon as you get as you are in power, you steal as much as you can, see, up to this maximum, whatever it is. And, well, you are sure that you will not be re-elected, of course, so but this is enough for you. Why? Because the value of being in power is not so high. I think this is the case in many, at least in some developing countries. You see, in which usually you see these rulers that are right there, as soon as they can stay there, they know that they will soon be fired, and okay, but they are. Okay, so this case is one case, but at least in other, well, most countries it is different. So let's say this is not the case, say, of a dictatorship in like. Think of my country like Pavia. This Pavia stayed there for a long time. See, they were not corrupt, or other things. That is usually, we assume that the value of being in power, that is different, is quite high. So here you drop a law, and then you are not able to recover. So the maximum is somewhere here. So it means that the government should have some level, P of T, that of course depends on the probability of being elected, PT bar. That is the level that should be stolen at all initial stage. Okay. So this is rather standard and simple. Let's move to, but of course it depends on the probability of being re-elected. Now I share the screen and I go further. Okay, what happens to the population? Well, here, while I say something about opinion polls and this, I would like to skip, well, for the moment, I don't write too much of this, so I stay here. Actually, go back to this. And sorry, I don't share, but I write from now on. I write on the black box because it's. But then, if you want the formal definition, you see them. They're both. So remember that we said that the reaction of the population is S-shaped. If somebody is familiar with the Ising model in ferromagnetic, this is more or less what is happening. That is, let's start assuming that people do not talk to each other. So what happens is that here you have the welfare, W, and here is the probability that you are in favor of the government. Here there is 50%. This is the welfare EW of T. And then you have some function that is like this. If you put everything together, that is the noise and this. If there is a lot of noise, this function is more flat. If there is little noise, the function is more sharply peaked. So say with little noise, we have something like that. Maybe. And this would be some the reference value. But You see, even with a lot of noise, if the population is large, we said they don't talk to friends. This is still the Condorcet case. The result is quite easy. That is, the probability that you are re-elected, you see, this is for one individual, but if you have many individuals, you will see that the noise cancels, so you got in this case. You see that the probability of being re-elected is high, is at least 51% if you are just a little above this. And if you are below, it drops dramatically. Okay? So everything is quite clear. You should try to give to the population W of 0. And if by chance, you see, you really get a bad draw, that is X of t so small that you are not able to give your W0, too bad for you, you will be fired. Of course, the population chooses W0 that is reasonable. So, you see, we are in the case of Condorcet. We are able to guarantee to the population if it is feasible. What happens in the other case? In the other case, suppose that everybody talks to everybody in this. What happens is that we have, again, now we put here the average opinion of the population. So this goes from 0 to 1. And here we will have this reaction curve again. Let me check this. So what happens here? Well, the picture is the same as before, but we assume here, you see, before we had here W0. Here W0 is already in the formula. It's here. It's already fixed. And we see that to W0 we have to add this other term, that is the average of the population. What does it mean? That the probability that you are in favor of the government depends on your welfare, as before, but also on what you heard from your friends during the day. Okay. So here we have, say, the average opinion, O is opinion, at day E. And here we have the average opinion at day D plus 1. Okay? And how does it evolve? Well, you see that it will evolve in this way. That is, of course, it's increasing. It makes, again, this shape. And then we see what happens to this dynamical system. That is, we take O of D plus 1, we put here, it becomes O of D, and we get O of D plus 1. So it means that we are looking at the intersections of this with this line. So suppose that we are here. Actually, to begin with, suppose that the parameter, and here the relevant parameter is the weight that you give to the other one. Suppose that this is quite low, so we will have something like, sorry. So this should be we see that there is only one fixed point. Okay? You start with some opinion, you see some favorable opinion. Well, maybe the next day the opinion will be even more favorable. This will be even more favorable, and so on. So the opinion that you have makes the opinion of the other increase, but only to a certain level, and then you stabilize at this point. What happens if you react more strongly to what are your friends' opinions? So this is the picture I had before. And this is the interesting. Well, suppose that you start thinking that the government is doing okay. You see, say 51%. Most people say. Well, you hear them, and you see that you will think, you see, the next day, the average opinion will be a little higher, it is 50%. The next day it will be higher and higher. Well, it converges to a very large consensus. Yeah. And you see, this consensus here is not really created by the welfare. The welfare was just as you giving, say, 51% or something like this. This consensus is given by the fact that you keep on hearing that, say, the first day you say the majority of the population, 51% of the population is in favor of the government. And you say, well, okay, I am about uncertain, so I should think that they are in favor. So some people start thinking that they are in favor, and then it effect probably can react there. Of course, we can have the opposite effect here. If you are more or less just below it, then they always think that the government is bad. So we have this two fixed point. Okay, and this is what happens in the end. So we now have to, of course, we have to prove it. This is not really a deterministic system. That is, you are here, there is a probability that you are around here, you have to estimate what is the probability that you are there. So, but there is a theory of large deviation, you see, a well-developed theory that in this case also is quite elementary and can be done, and can be done even in a rigorous way. You see, if things are more complicated, but this is all quite standard mathematics. I show you quickly the screen. Go back here. I know that people in 2013 should be able to make slides, but I am not. So I'm always looking for co-authors that help me in this. So yes, so we need some definitions, and we need, say, what I would say a definition of crowd behavior. So let's say this. We say that this process, you see, this is a stochastic process, and this, we say that there it is. We say that you can reach consensus OF from OI. OI was 51%, and OF will be in the picture we had before was 99. If for any epsilon and for a large enough population, you have that the probability that you will end up with this high OF is very large. See, it's larger than 1 minus epsilon, starting from anything that is of this. So the idea is that if we are in this case, we see that the consensus is kept because we reach after a certain number of days. Well, yes, here I have the number of days in the legislature. We are at this point here. That is, we converge. If these two values are the same, we say that you keep consensus. That is, maybe you start with 99% of the population that is voting for you, and you will maintain it. You drop consensus, what happens is that whatever is your starting point, it means that your system will drop below a certain level at some day d0. See, there is a d0 in which it drops. It may take some time, but you want it to do, if n is large. And you say that the village exhibits crowd behavior if for W above a certain threshold, just a little bit above, you can keep a high consensus. So this is more than 50%, and typically it's a high number, it's 90 of this. And if you are just a little below it, you see, these two numbers are the same almost. See, plus epsilon minus. If you are a little below, whatever you do, you start with, you drop to O minus. This is different from O plus. You see, there is a gap between these two. So it means that this consensus is not a continuous function. Okay, and this level will be called the satisfaction level. I go here and I show you the system, and I'm almost done. And then, of course, I'll be happy to hear your questions and remarks. What is the point? Is that if you give a O value to your friends, the picture is more or less like this. that is the consensus does not depend on the initial points, depends only on WC. If you give a lot of weight to your friend, so if you are in this close, and then I will tell you that it's not a question of weight, it's really a question of how the structure of this network is made. In this example, it's very simple. It is that everybody is connected to everybody. Then we will speak a little bit about this in the discussion. So we have a picture like this. That is the typical picture of the cell. That is, and this is the satisfaction level. You see, this was W0, the one we had before, and this is some other, some minus. And we are good. What does it mean? It means that if you are able to start from anything that is, say, suppose you are here. So in the first legislature, what is the optimal strategy of the government? In the first legislature, you give a lot to the population. So you gain consensus. So you are above this level. It is consensus. Oh, see the opinion of people when they vote. Then people are very happy. See, they're all voting for you. Then you go down. So you started maybe here, you were here, then you go down. You go below the satisfaction level, but people are still, what you are here. You give less than the satisfaction level, so you are corrupt, you are stealing this amount of money. But people still think that you are good because they talk to somebody, you talk to somebody, you talk to somebody, who talk to somebody that was happened a certain number of days before. Okay, so you stay there. On this, there is this party. The problem is that this is the crowd behavior. That is, here people are all voting for you, they're all happy with the government. Then suddenly, if you go below this level just a little bit, what does the crowd do? Well, at some point, people realize that you are doing bad, and they start hearing other people that say that you are doing bad, and suddenly your consensus drops. So what happens in this case with crowd behavior is that you have long periods in which a corrupt government continues to govern and has the support of the population. And I have to say, well, I don't want to say anything. Well, I say something that is, you see, again, in my country, for 20 years there was fascism. Then we had for 50 years the sort of system, well, whatever you want to call it. Then for 20 years we had revolution. You see, we have long periods in which, and you see, there were, well, not to be with fascism, but people were supporting fascism, at least till the war. And after after 45, the elections were more or less honest. People were honestly in favor of the government, even if the government, compared with other governments in Europe, was good. And but then suddenly, you see, for instance, in 1992 in Italy, people started complaining about the government, and they dropped. We were governed by parties, the Democratic Christian and the Socialists, that had high consensus, and in one election, they dropped. The Democratic Christian disappeared, and the Socialist Party had 0.5 of the vote or something like this. So we have this. So you can interpret this also as a revolution, if you want. And well, if you take an history, an illustration of this, and is the fact that if you are in countries that are more individualistic from this point of view, like the Anglo-Saxon country, you see that there are very few revolutions. You see, in England, they don't have a revolution since Cromwell. So it's what it is, but now what the 350 years. In United States, basically, you see, you have an alternation between Democratic and Republican forever. That is, well, the Republican Party was at the time of Lincoln, and the Democratic is even older, but before it had another name. So, and the transitions were smooth. On the other side, in countries in which people talk a lot of politics, you see, they go. Somebody said, well, since it's warm, people tend to go out and then they chat. Like Italy, you have the contrast. You have more or less the same government or the same system for a long time, and then suddenly this disappears. You don't want to hear of it anymore. You think that it's bad. Everybody thinks that it's bad. And this. So this is more or less the outcome. if you have questions, or maybe I make a couple of other remarks or whatever.
It's up to you. Maybe you can go first for questions, and then depending on the time remaining, you can go for additional remarks.
The question will be the occasion to make my remarks. So please.
Sure. So I don't know if Max has any question, and otherwise, are there questions in the room?
Yeah, I have a few questions. Oh, sorry. Can you hear me?
Yes.
Okay, I have a few questions for you, Stefano. Thank you for your presentation. Just about the US, about your last remark, it went smooth. I mean, it went smooth, except that the US had a civil war, you know, so it's not completely smooth.
Yes, in fact, yes, this remark, you see, I said this thing about the United States when I was presenting this some years ago. So I think that the reason is probably this one, that is that now, I mean, is internet. You see, the fact that everybody is connected to everybody. That is, before people were just, you see, they were reading newspaper. Well, this is something I have to say about this model. So, what are the reasons why we have this crowd behavior? One is the structure of the network of friendships. That is what we call friends. That is, it is not so much how many friends you have, but is the way it is shaped. That is how many loops it makes geometrically. Let's say in this way: how do I influence? I am here in Liguria. How do I influence somebody in Rome? Okay, I don't know. Okay, well, you see, the reason is that maybe I know somebody who knows somebody who knows somebody that knows him, and then I know another person that knows another person that knows another person that knows him. So it depends on how many paths of friendship, how many chains there are between me and this other person. You see, on each chain, what happens? Suppose that I am a fan of this government. Suppose that. I say the government is doing very well. So I have a probability that people I'm talking to, say, you see, this other one, changes his idea. There is a probability that this change makes the third one change, and so on, until we arrive at that person there. So the probability that I have to influence this person there is exponentially decaying in the length of the chain. So you would think that it's small. But then the problem is that there are many chains that I can form from me to this other person. You see, I can talk to somebody in Rome, I can talk to somebody in Milan, that talks to somebody in Venice, that talks to him, or I can talk to somebody in Torino, that talks. So if you, and you see the number of these chains is proportional to the number of combinations that you make. So it is increasing exponentially. So if the exponential increase in this sense is stronger than the exponential decay in the other one, I have a high probability of, there is a relative high probability that this person in Rome will change his opinion according to mine, or vice versa. And this is what creates this crowd behavior. This is a strong analogy with physics. You see, when you have a phase transition, you see, phase transition, you have really these correlations between points that are very far, not because by some reason, you see, when you have water that becomes ice, freezing water, there is no special change about the molecules. It's simply that below a certain point, each molecule influences all the other molecules in a three-dimensional thing. So if you think of a three-dimensional lattice, or a two-dimensional lattice, you see that there are many ways. See, think of playing chess. There are many ways in which you can go from one place to the other one. So, and these are exponentials. So this is the fact. So for instance, if people were living on a line in a one-dimensional, this would not happen. You see, if I am able only to speak to my next neighbor who speaks only to another neighbor and so on, there is only one path to meet. The line points, there is only one path. So this is fact. Another fact that is very relevant is that here we assume that there are only two opinions, favorable or against. Okay, or this works as well if you have a finite number, but a discrete number of opinions. You see, say few opinions. If you assume that people can can express their opinion in a continuous way, so I could say, well, I am in favor of the government with, say, strength 0.674, okay, a real number. Then you don't have this behavior. And even if you have a finite set of opinions, that is, if you have a large number, this gap between the two where you have hysteresis becomes smaller as well. So I think this is also something that is related also probably with what happens in the United States or in other places. That is, before opinions, people form their opinion by reading newspapers. So you were reading an article that was documented that, you see, it was shady. That is, you could say good, well, saying this is doing well. Now, if you just interact with Twitter, you see, you have a small amount of characters, so you can only say one thing. If you can say, I am in favor or I am against. You cannot shade your opinions in a larger space than this. Because, you see, if you could do this intuitively, what happens? Well, you see, I can say that I'm in favor of the government, and I can maybe influence the other one, but if the signal is bad, if the government is bad, this other one will say, well, I'm not 100% in favor of the government. I'm 90%, 99% in favor. See, my opinion is 100, weighted with a bad thing, even if it gives a high, you see, it's enough that it gives some weight to the signal. If the signal is bad, his opinion will be a little below 100%. And then, again, talking to another one or talking to other people, it will influence people not with 100%, but 99%. So after a few days, you will see this decay. There was a paper of Matt Jackson that it was, say, another version, a little more simple than this, but it was exactly this. That is, the title of the paper is The Wisdom of Crowd, because it assumes that opinions. So I think also that this shows, you see, usually I am very suspicious of politicians that like a lot of Twitter or this type of, you see, that give these simple, short messages, this, because it's exactly playing in this way. That is, either you're in favor of me, you see, you compel people to polarize. That is, either you're in favor of me or, see, who is not with me is against me. There is no possibility of, and this is, of course, also, you see, what you see is that dictatorships like a lot making, you see, you would think, well, dictatorships should try to prevent people from communicating and this. This is partially true, of course, there is a control of media and this. But I think successful dictators want people to interact a lot. You see, they make these youth groups, they make all these communal, well, of course, when there was not internet, there was all these reunions. You see a lot of people that were going in the streets, they were manifesting this, so that this was really a way of strengthening consensus. Well, okay,
Thank you. I have another question for you, which is, so actually I have two other questions, three actually. So the first one is, so in real life, people don't know the law of capital X. So, you know, how should we deal with that? So that's my first question.
Yes, people don't know. I did not hear what they don't know.
The probability law of capital X.
Yes.
So that's the first question. The second is, what's happening if we change the majority rule and we say when they vote, each voter has like 10 points and distribute the points among the two candidates, and the winner is the one who gets more points.
Yes.
As you know, it's much more clever than the majority rule. Would this change something in what you just described? Maybe it has the same effect as having a continuum of opinions. I don't know. I haven't thought about it.
Yes, it is.
And the third question is, can you go back a little bit to the large deviation theorem that you said is very classical, but I'm not sure it's very well known here.
Okay. Yes. So, yes. So the first question was about the probability law. Yes, no. Well, you have to assume that the population knows that the probability law just for comparison. That is, in the case in which you have a principal agent model, that is, assume that people are rational, so they know the probability law that they compute, and then you see that they can guarantee a certain level. Otherwise, the model, yes, I forgot saying it, that is, after this, they don't need to know the probability law. It is simply a behavioral model. That is, they react simply to what they see, and if they, you see, if they're happy with what's happening around, they tend to be in favor, together with the opinion of the others. Yes, when you say of voting with points, is more or less this said. Well, voting with points means you have several opinions, not just +1 and -1. You can say, and in fact, I think this would be, well, you see, you know very well that there is this, there are these voting rules, the Borda rule, and this are in this case. So, and in fact, they were invented probably to ensure, you see, also Le Bon, all this. There was this period at the end of the 19th century in which, you say, Ortega-y-Gasset, many people were speaking of crowd and crowd behavior. And this was, of course, because it was the period in which the electoral basis became larger and larger. That is, there was universal voting and this. So, and in fact, you see, contrary to what they were expecting, you see, they were expecting that probably politics would have become better, and we would have, but they were already seeing that things were not really so. And so Borda developed, I think, this. And yes, that is, if you assume that you can say you can go around instead of saying I'm favorable of the government, I give the government 10. You can say I'm favorable, but I give only 6. Then this behavior becomes smaller and smaller. So in the limit, in the continuous limit, it disappears. I forgot the third question now.
Third one was about the large deviation theorem. If you can just
yes, large deviation theorem. Yes. Well, this is a way to study dynamical system in which you have some noise. So let's go to this example. As I said, we have, say, 1 million of people. Each one is favorable to the government with a probability of 67%. So you would say that in an election, the government would get 60. You see, it would be very close to 67%. But of course, there may be small deviation of this. It will be 67.01 or 66.99. The theory of large deviation says is a way of dealing with, as it says, the probability that is very low, that really there is a surprise. That is, you see, you throw a coin, to make another example, you throw it, you see, if you throw a coin, say, 1 million of times, the probability that the average will be 0.51 is ridiculous. It's very small. This is, if you throw, this is the central limit theorem. If you want to go beyond, you say, okay, well, it will be small, but how small it will be? Then this is the theory of large deviation, and it says that it becomes smaller and smaller exponentially in the number of, that's why it becomes very small, in the number, say, here, of voters, but still it's not 0. And this would explain, but it is not the case here because N is so large that it is something like that is at some point you will have a sudden jump, even if the government is still above that level. But this jump will, you see, in a large population, say if N is larger than 10 or 100, it's totally ridiculous. It may have some meaning if you have small groups. you see. And okay, but this theory, you see, there is a book of Friedling and Wenzel. Friedling, particularly Friedling, Wenzel then added something that he was a Russian, and that this with it. Essentially, you have a differential equation, an ordinary differential equation, some dynamical system, continuous. You add a little bit of noise, and you ask, suppose you have a differential equation which, well, I'll show you something like this. Actually, it is important also for climate change, because there is a theory that glaciations really come from this. Suppose you have a system that is like this. So you have, well, a little ball that moves, and gravity, it can be either here or here. And suppose this, of course, is a absolutely trivial simplification. Suppose this is your climate. Okay, so the climate can be either in this status here or in this one. And suppose that this one is normal and this one is the glaciation. The glacial period. Then you assume that this ball is not really, it is moving a little bit. Suppose that the blackboard is vibrating. Okay, so the ball is here but oscillates around this point. So there is noise, something like that. Well, then there is a small chance that you have, you see, a little bump here, and then a little bump here, a little bump here, and then at some point the ball jumps here. Okay? So this is exponential in the inverse of the noise, but say if the time scale is million of years, it may happen. So you jump to this level, and once you are here, this is a metastable state. You stay here. You see, it's not that you go back. It is the ball is here and then starts vibrating along this. So this would be, say, a glaciation or something like that. And then you jump back. But there is a way of quantifying. You see, the probability that you jump from here to here is smaller than the probability of jumping from here to here, because this is higher. So it means that you will have this state for a long period, and then you will have some it will be interspersed by shorter periods in which you are here. So this is, say, the version. And yes, the mathematics is, well, by now it's well known. You see, I think, you see, the standard reference, if you want, I send it to you or to people that are interested in this book of Wenzel and Friedling.
We have it here.
Hey, speaking of dictatorship, Friedling wrote this book when he was in a gulag. And so the referee of the book, I read the referee said, well, the book was, you see, praised on all levels. And the last phrase that, well, I have only some remarks about the incompleteness of the bibliography, but he says, but I understand that when you write in a gulag, the library there cannot be the one that you have in an American university. So it was also an homage to the endurance of Friedling. Thanks. Other questions?
So Stefano, I have to leave, unfortunately. So talk to you soon.
Yes. So okay. Have a nice trip.
Thank you. Bye-bye.
Bye, Gail. All right. Are there any other questions in the room?
I think we are good. Yeah.
Thank you very much.
Okay.
Thank you very much for that.
Yeah, I think except if you have important concluding remark, we can stop here because it's pretty much time. Up to you.
Okay. I don't know how much time I had. It was 1 hour or 1 hour and 1 half. Or...
yeah, we've almost run out of the 1 hour and a half. So.
Oh, okay. So yes, no, I stop here. And many thanks for your attention. And I hope we will keep in touch.
Well, thank you again for this presentation, which was very interesting, and for having accepted to present. That was great.
Well, Gail knows me, and I'm hopeless. I'm old now. There is no space for improvement. Many thanks. Bye.
Many thanks. Bye.
See you.
Bye.